Alright, Rolle's theorem and mean value theorem are the theorems we'll be talking about today. Now, Rolle's theorem is pretty sweet and easy to understand, but it's kind of hard to really work with. Okay, so first off, we'll take a look at an actual graph. Okay, so let's say we actually have something right here, and let's say we had the function something that looked like this. Okay, an actual parabola. All right, now what it's saying is that at the same y value, we're going to get there's going to be two x's where we get the same y value. And so that what that's saying is that somewhere in here, there has to be a line that is tangent and therefore horizontal to the actual graph. Okay, so that's what Rolle's theorem is saying. All right, and so let's say the example was f of x equals x squared minus 5x plus 6. Okay, and since f of 1 equals 2, and so in other words, when I plugged in 1 I get 2, and when I plug in 4 I also get 2. Okay, so that means somewhere between 1 and 4 I have to have this point where I'm making a horizontal tangent line. Okay, now the best way to find that is to go ahead and do the derivative. Okay, so when I do the derivative, it's going to be f prime of x is going to be equal to 2x minus 5. Okay, so that one's pretty simple. And what I'm going to do is I'm going to actually set it up equal to 0 because the slope of the tangent line is going to be 0. So that means the rate is going to be 0. So this is going to turn into 0. And I have 2x minus 5. Okay, and then I find out that x is going to be equal to 5 halves. Now what that's doing is that's giving me the point at which it's happening. So that's giving me this 5 halves right here. So this is going to be the 5 halves. Okay. Now, in order to find the y-coordinate, I have to take this value and plug it into here and actually find it. And what I'm going to find is that when I plug in into the original function 5 halves, I'm going to get out 1/4. Or, sorry, negative 1/4. Screwed that one up. Okay, so that means that there's a horizontal tangent line passing through this point at 5 halves, comma, negative 1/4. Okay? Alright, and so that's what Rolle's theorem is actually doing. Now, mean value theorem is actually kind of using something a little bit similar to it. Okay, now let's say we were using the same exact function except we were going on the interval from, it doesn't matter what interval you use. Let's say f of 3 is going to be 0, and then f of 5, something increasing. F of 5 is going to be 6. Okay, something pretty simple like that. So what I would first do is I would find the slope. Okay, and the slope would be 6 minus 0 divided by 5 minus 3. Not 5.3, but 5 minus 3. Okay, and that would give me a slope of 3. Okay, so that's pretty simple. And so what I would do is I'd again look at the derivative, which is the formula to find the slope of the tangent line. So that would be 2x minus 5. And instead of plugging in 0 this time, I'm going to plug in 3 because that's the slope I'm looking for. That's the slope of the line between these 2 points. So let's say if we were to say this was 3 and this was 6 right here, I've just found the slope of the line between those 2 points, which is about to be 3, which makes sense and it looks pretty darn good when you actually draw it out. So that's 3. Okay, so what I'm saying is that the mean value theorem is saying that somewhere between 3 and 6 there has to be another line that is also tangent and parallel to that first line, and it will actually tell me where that is, and it will actually say that that line is also a slope of 3. And I use the derivative to get there. So 2x minus 5. Okay, if you notice, this is a lot like the Rolle's theorem. Okay, so I get 8 equals 2x, and then 4 equals x. Okay, so 4 equals x, I take that 4, I plug it back into the original equation, so I get f of 4 equals 2. Okay, and so what that is saying, come on. At the point 4, 2, the tangent to the curved line is parallel to the segment drawn from the endpoints of the interval 3, 5. I'm sorry, 3, 5. I was saying 6 and stuff. Okay, and so what that's saying is that this point is going to be 4, 2. Which with my crappy drawing looks pretty decent, or at least somewhat, hopefully, decent. Okay? Alright. So that's just all set up and stuff, and that's exactly how it works. It's a gorgeous little thing that actually works. So at that point, I'm going to actually have a line. Now, what does that mean in reality? What that means is that if I was driving from like here to San Francisco, and I started here at 0 and ended at San Francisco at 40 miles an hour, somewhere along the line, my speedometer exactly hit 20 miles per hour. Hit exactly. Doesn't matter if it's in the beginning, doesn't matter if it's the end. When I slow down, somewhere along the line, it had to cross that. And what that just means is that there's somewhere along this line where my rate has to be there. So this stuff is actually used quite a bit when using to try to explain where derivatives come from and where that c comes from when you're going to be finding that. Okay. But if you just take a look at these two examples and just use them, I think these are just some great examples that help explain mean value theorem and Rolle's theorem all together. Okay. Thank you very much. Have a great day. Bye.